So far, we have looked at equilibrium reactions in terms of the qualitative assessments of what is going on now. What we're going to do is to learn how to write the law of mass action, which allows us to quantify the ratio between equilibrium concentrations of our products and reactants in an equilibrium reaction. I read the chapter last night, and it also mentioned equilibrium expression. Is the law of mass action the same as equilibrium expression? Yes, equilibrium expression is interchangeable with the law of mass action. By the way, it is always a good idea to read the relevant text and engage the material first at your own pace before coming to the lecture. That way, you already have a sense of what you understand and, more importantly, what you don't understand, so that you can pay more attention during the lecture. Well, let's continue. In order to assemble the law of mass action of an equilibrium reaction, we have to first make sure the chemical reaction is balanced. Here is a general way of writing a chemical reaction. A molecules of A plus B molecules of B react to give C molecules of C plus D molecules of D. Then the law of mass action is the product of the equilibrium molar concentration of products divided by the product of the equilibrium molar concentration of reactants. Each concentration of reactants and products is raised to their stoichiometric coefficient as their power. Again, the equilibrium molar concentrations of the products are in the numerator, and the equilibrium molar concentrations of the reactants are in the denominator. As it is illustrated here, the equilibrium molar concentration of C raised to the power of C multiplies the equilibrium molar concentration of D raised to the power of D divides by the equilibrium molar concentration of A raised to the power of A multiplies the equilibrium molar concentration of B raised to the power of B. The numerical value is known as the equilibrium constant, and we use the upper letter K to represent an equilibrium constant. The subscript C is used to indicate molar concentration. We will learn different subscripts later in this course to describe other reactions. Finally, equilibrium constants do not have a unit associated with them. Any questions? Nope. So far so good. Now, we have a general formula for assembling the law of mass action. So, let's look at the previous example of the decomposition of dinitrogen tetroxide into nitrogen dioxide. How could you write the law of mass action for this equilibrium reaction? First, I would like to check to see if the given chemical reaction is balanced. In this case, 1 dinitrogen tetroxide yields 2 nitrogen dioxide. Now, I'm ready to write down the equilibrium expression of this chemical reaction. In the numerator, I have the equilibrium concentration of nitrogen dioxide and raise it to the second power because its coefficient is 2. In the denominator, I have the equilibrium concentration of dinitrogen tetroxide and raise it to the first power because its coefficient is 1. Perfect, Benjamin. That is how you write the law of mass action for a homogeneous reaction as both the reactant and product are in the gas phase.